Hi, everyone. This is Mrs. Haynes. Since I forgot to teach 4.1, I'm going to do it here. It should be a fairly short video, and if you want to just get it from the book, that's fine too. So if you have your book, I want you to open it to page 219. First of all, we talked about congruent before. Congruent up until now is only meant line segments. So two line segments are congruent if they have the same length. Two angles are congruent if they have the same measure, meaning the same degrees. The idea of congruent polygons is, first of all, polygon is a closed, straight-sided shape. So we have two quadrilaterals here, and two polygons are considered congruent if their corresponding sides and corresponding angles are matching. So I want you to look at this picture. Notice that they tell us that polygon ABCD is congruent to polygon EFGH. Each letter represents a vertex of the polygon, and so the order matters. So because they listed ABCD, A is first and E is first, those are corresponding angles. So that means angle A is congruent to angle E. Same thing for B and F, since they're both second in the picture, in the congruent statement. I'm looking at this statement right here. Since B and F are both in the second location, angle B is congruent to angle F. Also, angle C is congruent to angle G, and angle D is congruent to angle H. Notice it's not because they happen to be alphabetical. The reason it works is because they're in the same location in this. It's a little bit harder to see, but you can also put two segments together. Since G and H are next to each other, line segment GH is congruent to CD. And since D is last and A is first, line segment DA is going to be congruent to line segment HE. So basically, kind of the theme for writing congruent statements in this whole chapter and really the rest of the year is you've got to make sure you have corresponding angles and corresponding sides in the right spot. And it means something a little bit different than what it meant in chapter 3. It just means the same location. So if you look on problem 1, finding congruent parts, they told us that HIJK is congruent to LMNO. And at that point, you can match up the angles easy. Angle H, angle L are congruent, J and N are congruent, K and O are congruent, and then the sides work as well. Since MN are the two middle letters and IJ are the two middle letters, line segment IJ is congruent to line segment MN. So you need to be able to find congruent. If you're given a congruent statement for polygons, come up with the congruent parts. If you're given the congruent parts, come up with the congruent statement. Okay? And the next one didn't cover too well, so I'm going to go to the whiteboard for this one. But if you want to look in your book, you can look at the top of page 220. I'm just going to do a quick sketch of this. So just some reminders. Triangles can be identified by their 3 vertexes. And they told us these 2 angles were congruent. So everything I'm drawing in purple is what's given in the drawing. Erase a couple things. Okay, so that's what's given in the drawing, and we need to figure out if these 2 triangles are congruent. So first of all, you can look on the drawing, and we know that angle B, based on the markings in the drawing, angle B is congruent to angle D. We also know from the drawings that line segment AB is congruent to line segment DE because of the congruent markings in the drawing. Because BC and CD are both 4, we know that BD is congruent to, BC is congruent to DC. And we also know, since AC is 6 and CE is 6, we know that AC is congruent to AE. So that gives us 1, 2, 3, 4 things based on the drawing. So we have one angle and 2 sides. Okay, the next thing that we know is, I want everybody to look at the green markings that I'm getting ready to do. Change colors. I want you to notice this angle and this angle, and think about that relationship. What's the relationship between the angles where those 2 little green dots are that I did? Those are vertical angles. And what you know from chapter 2 and chapter 3 is vertical angles are congruent. So we can add congruent markings. Now we have now we know that angle, and because there's 3 lines coming in, we have to use more descriptors for this one. We know that angle ACB is congruent to angle DCE. Okay, so now we have 2 angles and 3 sides. Now, there's something else. If you look on the bottom of page 220, or the middle of page 220, look at the third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. And that makes sense because they have to add up to 180. So if 2 out of 3 of them are congruent, the other one has to be congruent. So because of the third angle theorem, I'm going to add this in pink. We know that that angle A is congruent to angle E. And now we know, because all 3 angles are congruent and because all 3 sides are congruent, we now can write a congruent statement. So the congruent statement we can write is triangle, and it doesn't matter what order you do the first one. I'm going to do triangle ABC is congruent to, but now I have to be careful because I know angle A, whatever letter I put first and the second one, it's got to be a match for A. So I look on the drawing, and A is congruent to E, so E is going to go first. B is congruent to D, so it's going to go second. And C is congruent to, this is also ends up being a C. And so that's how you get the 3. It's always easier on these to start with your congruent markings that are single letters, and that way it'll work out. And so the answer is, we do know it, and we knew 4 out of the 6 because it was in the drawing. We came up with this angle because they were vertical angles, and we came up with these 2 angles because of the third angle theorem. And that's what building proofs is. You're going to have some answers that are because it's given. You're going to have other answers because of relationships that you've already determined. So just a reminder for you guys, the ones that are going to be important to remember are all the ones we've learned in chapters 1, 2, and 3. So I'm going to list those real quick. So just make sure you have all of these relationships, because you will use these to prove congruence. We're going to have linear pair. That's the 2 that are linear pair, same side, interior. Those are going to be supplementary, and they'll come up indirectly. For congruence, and obviously these all have to do with if 2 parallel lines are cut by a transversal. We know the following are going to be congruent: alternate exterior, alternate interior, and corresponding. We also know that if 2 lines cross, vertical angles are congruent. So that'll be another reason that we're going to be using a lot. And then the last one that comes up is the third angle theorem. And that says if 2 angles, and this is the one at halfway down 220, if 2 angles in a triangle are congruent to two angles in a second triangle, then their third angles are congruent. So those are going to be some ones that you're going to be using a lot. And just a reminder, every angle has three sides. Every triangle has three sides and three angles. Every quadrilateral has four sides and four angles. And two polygons, whether they're triangles or quadrilaterals or even pentagons or hexagons, if all the corresponding angles are congruent and all the sides are congruent, then the two polygons are congruent. And congruent means same size, same shape. That's it. I hope everybody has a great week, and I will see you next Wednesday. Bye.